Okay, let's talk about the conversions from one coordinate system variables to another one. Let's say you have been given the Cartesian coordinates of a point P. Let's say the coordinates are given as x, y, z, and now you have to convert them into the spherical coordinate values for the sake of your calculation to make things easier. Let's say you have to convert the x, y, and z values into the r, theta, and phi values. So how will we do it? So here in this picture, I have shown the x, y, and z coordinates in the red color, and the other color is denoting the spherical coordinates. Okay, if you remember, this is a right angle, right? And this is another right angle. So if we name this point P prime, this point over here M, then from the OMP prime right angle triangle, we get OP prime square equals to x squared plus y squared, right? And then again, we have proved it before, I guess. From the OPP prime right angle triangle, we get r squared equals to p prime p squared plus op prime squared. P prime p squared equals to z squared because p prime p is the z coordinate of the point, right? And op prime from this equation is x squared plus y squared. So from here we can conclude r equals to root over x squared plus y squared plus z squared, right? Now, what about theta? Theta will be equal to, this here is a little tricky. Okay, let's name this point over here L. So from the right angle triangle, this is a right angle, all right? Of course. So if this is a right angle, then OLP is right angle triangle, right? And tan inverse LP divided by uh, OL equals to theta, right? But LP is just the same as OP prime, right? So that gives us tan inverse root over x squared plus y squared, and OL is just the elevation of P point from the xy plane, so this is Z. Okay, so we can write theta equals to tan inverse x squared plus y squared divided by Z. And then finally, phi will be equal to tan inverse y by x. This can be derived from the right angle triangle OMP prime. Okay. Now let's say you're going to retrieve the Cartesian coordinate values from the given spherical coordinate values. So how can you do that? Okay, first of all, you know the value of r, you know the value of theta, and you know the value of phi. So if you take r cos theta, then you will just be getting the component of r along the z-axis, all right? But if you take r sine theta, then you will get the component of r on the xy plane. Okay, that means this shadow, this OP prime shadow over here, will be derived if you simply take r sine theta. So first we just take r sine theta to take the shadow of r onto the xy plane, and now if we take OP prime cos phi, we will get the component of OP prime along the x direction, and that will be the x coordinate that we are trying to get. So here, taking r sine theta, we are taking the component of r on the xy plane, and then we take the component on the x-axis with a cos phi. Thus we get to the x coordinate of p. Instead of taking the cos phi component, if we took the sine phi component, we would get the component of OP prime along the y-axis, and that will be the y coordinate that we're intending to get. So r sine theta, sine phi would be the y coordinate. And in the beginning, instead of taking r sine theta, if you took r cos theta, you would just project r onto the z-axis, and that would give you the z coordinate. So r cos theta will give you the z coordinate of it. Now we'll talk a little bit about the limits of the variable. All right, let's start with the spherical coordinate system. The radius of the sphere can be as small as 0, which will mean it's concentrated into the origin. So it can be as small as 0, and it can increase up to infinity. So the limit of r will be like this. To get the phi angle, we start moving the radial line from positive x-axis and rotate it into the anti-clockwise direction, and if we complete a full circle, we get back to the positive x-axis again. So the limit of the phi angle would be 0 to 2 pi or 360 degree, whatever you call it. And the limit of theta will be starting from 0. That means the radial line is superposed on the z-axis, and as you increase the theta direction, the maximum angle you can rotate until you get to the minus z-axis will be pi or 180 degree. In case of the cylindrical system, however, the variables are different, are phi and z. The radius of a cylinder can be as small as 0 to infinity. The value of phi being sort of similar as the spherical coordinate systems one will start from 0, and it can move up to 2 pi or 360 degree. And the value of z can extend. The cylinder we're talking about can extend up to minus infinity to plus infinity, from minus z direction to plus z direction, so there's no limit on that. All right. And finally, in case of the Cartesian coordinate system, you can move along the x-axis from minus infinity to plus infinity, and this is the same case along the other two axes as well. So the limit will be something like this. All right. That concludes our coordinate system part.